Our next speaker is Professor Lynne Jack, and Pete mentioned her name earlier. She is Director of Research at the Heriot-Watt University's Malaysia campus. Before moving to Malaysia in 2017, she worked for 24 years at Heriot-Watt's Edinburgh campus. And there's a bit of a difference actually there, isn't there? I mean, different climates for one thing, but she moved to Edinburgh. She was at Edinburgh for 24 years, a key member of staff supporting the delivery of building services engineering and architectural engineering programs. Her research focuses on modelling the flow characteristics in vertical drainage stacks and in building roof drainage systems, as well as on predicting simultaneous design flow for water distribution networks in buildings. Lynne's also president of the Chartered Institution of Building Services Engineers. She's co-founder of both the Scottish region of the Society of Public Health Engineers and the CIBSE Inclusivity Panel. Please welcome Lynne Jack. You must have changed your entire wardrobe.
Thank you, Rob, for that introduction. Good morning, everyone. It's a great pleasure to be here. Fantastic opportunity to see everyone again and to speak at the WPC. I've been asked this morning to speak on research and new knowledge and to try and connect this with the 4 pillars of plumbing. And I'd like to, if I may, just... So the one I'd like to focus on this morning is the participation pillar. So looking at training, knowledge, and education, and linking this with research. If I can ask you to think about what you perceive from academic institutions that undertake research. Do you see the ivory tower, or do you see the opportunity for collaboration that we've heard about this morning? And what I'd like to do, hopefully by the end of the presentation, is to highlight that if we do collaborate, we have an opportunity to be able to access much more knowledge and to apply that in the industry and to really be able to make a difference. As academics, one of the things that we enjoy most is working with industry. We are absolutely desperate for you to bring problems to us so that we can then investigate those. We're always a charity, or most academic institutions are charities, and that means we have no commercial interest. You get a very independent review of the research, and we enjoy working with industry. We enjoy solving those problems. So what I'd like to do today is to show you an example of something that we've done through the university and working with other organisations, and to try and demonstrate, if I may, that we don't sit in ivory towers, that we are very keen to work with industry and to try and directly deal with some of the challenges you have. To do that, I'd like to connect a number of organisations together. So I'd like to talk first of all about the university and what we do. You've heard Pete DeMarco mention this morning the CIB. The CIB is the International Council for Research and Innovation in Buildings and Construction. And I'd like to tell you a bit more about the commission that Pete mentioned, the CIBW 62 Water Supply and Drainage for Buildings Forum. I'd also like to mention Innovate UK, which is a UK government organisation that connects or brokers deals between academic researchers and commercial bodies and industry. And then I'd also like to mention CIBSE, the Chartered Institution of Building Services Engineers, with whom we have been working on some of these industry challenges. And hopefully by connecting the dots and telling the story of how we're able to address industry problems, I'll be able to give you an example of how we can directly address some of the challenges. So first of all, Heriot-Watt, you heard in the introduction, we are a Scottish university. We're very international though. So our base is in Edinburgh, so top left photo. We also have a campus in Dubai, though, where we have around 4,000 students. But in total, we have 30,000 students internationally. So we have many, many international partners. And you heard today that I'm based at the Malaysia campus, where we now have around 2,000 students. We are in the business of education and knowledge. That's what we do. And the reason we do that is for the benefit of society. There is no other reason. There's no commercial gain. It's purely for the benefit of society. So in terms of the university, and in particular in Malaysia, we focus on, if you don't know the university, we're a very small technical university. We focus on engineering, construction, business, actuarial science and psychology. And we offer PhD degrees in these disciplines. So we're a relatively small university. We are very technical and we're very industry facing. I don't have time this morning to go through the heritage and the history of the university, but we were born of the industry linkage that came from the UK and in particular in Scotland 200 years ago when we needed to have better access to education in technical subjects. And one of our specialisms is in public health engineering and plumbing. So what we do through the university, the areas we work in, if I can go through them, we look at internal building drainage, so sanitary appliances, and that's mainly performance issues. How do those sanitary appliances perform? We also look at small-scale local drainage and runoff from the curtilage. So we look at not only what happens inside the building, but in the locality outside, but all within the boundary. So although we can partner and work with civil engineering colleagues, we tend to look at what happens within the curtilage. And obviously included within that is rainwater drainage. So we look at both conventional and siphonic rainwater. And then we also look at water supply. So one of the things we've spent a long time talking about now is loading, and you'll have heard mention of this several times already. When we try to introduce, or we aim to introduce, water conservation into buildings and use less water, that inevitably has implications for our water supply system and the sizing of that system. So we spent time talking this week at the CIBW 62 about water loading characteristics and how we can actually predict the demand. The way that we do this at Heriot-Watt is through numerical modeling. So that's our expertise. That's what we bring to the industry. And I've listed here the models that we work with. Again, we don't have time to go into detail, but we work on air pressure transient propagation, so looking at building drainage ventilation systems and pressure responses. We model free surface flows in drainage lines, so free flow characteristics and how we can look at solid transport inside drain systems, predominantly from the building to the main sewer connection. I mentioned siphonic systems. We look at modelling siphonic systems and how they prime. So that's you'll know that's a very dynamic part of their operation. So in particular, the priming phase before they move to full bore. And when we superimpose the implications of climate change, in the UK we have access, and I think you do in Australia as well actually, access to very good climate change data. So when we overlay design flows into those siphonic systems, how do we see the behaviour of the system change? And then I mentioned simultaneous water demand. How do we predict that within a building? So these are the two that I'd like to give you the example of. Again, coming back to this issue of collaboration and working with different bodies to be able to deliver education and new knowledge to the industry. I mentioned CIB, and Pete mentioned this morning. So as I said, it's the International Council for Research and Innovation in Buildings and Construction. It has been around some time. It was established in 1953. And now has 13 task groups and over 30 working groups, of which CIBW 62 Water Supply and Drainage is one. So as Pete said, we met earlier this week. Our meeting ran from Sunday through to Tuesday evening. It was very successful. We had 38 technical presentations. And I know Brad is in the room, Brad from Hydraulic Solutions by Design, Brad Williams from Canberra hosted, and we're very grateful, Brad. It's the second time we've managed to come to Australia in the history of CIBW 62, and I think this time hugely successful. And I will share with you some of the topics we covered. So I know the text is small here. I'm going to make sure you can see some of the detail by identifying these with the red lines. Just to highlight a few things that we discussed, and it is just a snapshot. We talked about Legionella prevention. We talked about hot water circulation temperatures. We talked about how to be able to dispose of food waste in universities. And we talked about cold water pipework sizing for the National Construction Code in Australia. Just a few examples. We also had a number of sessions on simultaneous water demand. And again, I'll come back to this as this is the example I'd like to refer to today. Some other examples, we also talked about net zero water in buildings. We talked about high-rise and drainage provision and how to be able to size our systems for those very high-rise buildings. We talked about green walls. Again, we've heard about this morning. And we heard from Pete and Steve Cummings on the development of the ISO standard for water-efficient products. So hopefully that's given you a flavour of the type of things we cover in CIBW 62. Pete did also mention the future meetings. So next year we're meeting in Taichung in Taiwan. And I'd just like to highlight the special session we have, which is on the demand in buildings, the water supply in buildings, how we actually predict the simultaneous demand. It's very, very topical internationally. And what we found through CIBW 62 is that we've seen a number of models emerge on how to be able to better do this. So if you understand the challenge here, we have water conservation in buildings, particularly big buildings. And that means that the traditional loading unit method that we have used for many decades actually oversizes the system. We have oversized pumps, we have oversized pipes, we use more energy than we should, and we need a better method to make sure that we can reduce water consumption and still have the correct systems to deliver this. So in recognition of that, in Taichung next year, we will have a special session on predicting water demand in tall buildings. In 2021, we'll meet in Belgium, and we have a plea actually to meet in further west, so hopefully in the United States or Canada in 2022. So coming back to the example then, I mentioned earlier CIB, we've now covered, and Innovate UK. Innovate UK, as I mentioned, is a UK government body, and they help broker deals between academic research institutions and industry. So they're really a UK agency. They focus on innovation. They're sometimes known as the Technology Strategy Board, and they're a non-departmental government body, a public body. They do operate at arm's length from government. They're not directly related to government, but they operate through an organisation called UCRI, so the UK Research and Innovation Network, and they're funded by the Business and Energy and Industrial Strategy Unit through government. But they're very, very successful in partnering. You heard Pete talk earlier this morning about how to partner research and industry and to find funding. They're very, very successful in partnering the bodies that are able to then deliver research and new knowledge against the industry challenges. And in this particular example, we've worked with Subsea, the Chartered Institution of Building Services Engineers, to look at this issue of predicting water demand in buildings. So for those that don't know, the CIBSE is a professional body. We have around 21,000 members internationally, of which are just under 1,000 are based here in Australia. We're licensed by the UK Engineering Council, and we are again a registered charity, so not commercial. The main aim of Subsea is to develop knowledge and education in support of improved building performance, again for the benefit of society. We advance education and research in building services engineering. That's what we do. So as part of Subsea, we have a number of divisions. They include light and lighting, facade engineering, digital engineering, local exhaust. But the one of most relevance here today is the public health engineers. So Public Health Engineering Society within Subsea has around 1,250 members and 68 industrial members. We've 5 UK regions, 1 in the UAE and 1 pending in Qatar. And the treasurer of SOFI is based here in Sydney. One of the challenges that we're very, very aware of, and coming back to the 4 pillars of plumbing, is education. So one of the challenges that we faced for such a long time, and actually I don't really have any ideal answer here, but we're very aware of the skills gap in plumbing and public health engineering, and it's something that we've tried to tackle for some considerable time. Part of the solution led to the launch of the SOFI and the CIPHE. So the CIPHE is the Chartered Institute of Plumbing and Heating Engineering, and Kevin is here, who's a chief executive, and will know the Plumbing Centre of Excellence as well as I do, if not better. That came from this identification of the skills gap. We're very, very conscious that it's very difficult to recruit plumbers, to be able to train them, to offer CPD. And I know from my own university perspective, even recruiting in building services and public health is incredibly difficult to do. It's not necessarily a language that 16 and 17-year-olds recognise readily. So the Plumbing Centre of Excellence offers CPD courses in, for example, Legionella, high-risk drainage venting, water demand and rainwater design. And the plan is to extend this model across the UK to be able to pick up on this skills gap that we've identified. And SOFI through Subsea is offering bursaries to some of the registrants. So hopefully this will be able to make an impact in terms of education and filling that skills gap. When you talk to SOFI members and some of the teams charged with running SOFI, and you look at the challenges that the public health engineering sector faces in the UK and internationally, this is what tends to come to the fore. So increased cases of elevated water temperatures in buildings, so exacerbated by this air tightness issue that we now see in buildings, and also infrequent use. We've talked about demand loading calculations and the oversizing of pumps and pipes, and this really is an energy consumption issue as much as a water issue. Climate change we've also heard mention of, and stormwater attenuation. And technological change, something that we're very conscious of at the university level as well. As we move towards IoT and AI, as we look at modelling systems and smart technologies, how does the role of the plumber change? How does the role of public health engineering change? And we have to be very, very conscious of this. And then finally, fire safety and suppression systems. Something that's very much of the fore of the Subsea members at the minute is related to fire safety in the aftermath of the Grenfell disaster 2 years ago. So to come back to the pillars of plumbing and this issue of participation, we recognise the skills gap, and sorry, I've gone the wrong way, sorry. sorry, off track. So to come back to the demand loading calculation and the example of collaborating and working together. If I can bring you back to this diagram here, what I've done is I've superimposed SOFI, Society of Public Health Engineers here, so that we can see how this comes together in terms of the project. You also heard Pete mention this morning about the PERC organisation and some of the lead-ins to how to get funding in this issue as well. We've done pretty much the same thing in the UK, and this is why I say there are a number of models now looking at demand prediction in buildings. But the point here is about collaboration, not necessarily about the output. We talked about the output in CIB earlier this week, but here the message is that as a university and with the support of Innovate UK and working with Subsea and with SOFI and with CIPHE, we've been able to develop a project, it's a 2-year project, almost at the end now, to look at how we can better estimate the design flow for water services, in this case in residential buildings. We're also working on a sister project for non-residential buildings. As I say, the design method and the outputs I will show you quickly, but they don't particularly matter here. We talked about them earlier in the week. But the aim here of what we're doing is we're looking at being able to predict the design flow using a stochastic model and using Monte Carlo simulation techniques. Now, the models we talked about, they all differ slightly. They all do something slightly different in the approach and both the outcome. And one of the reasons that CIBW62 is important is we then have a platform to be able to bring those models together, to compare and to contrast, and to actually take the best parts of all of those models and to share knowledge, again, for the benefit of industry. So from the Heriot-Watt model, I just want to show you one slide on results. What you see here in the blue line is the output from the prediction model. And really what this is doing is predicted against, you can see a couple of green dots, which are the measured flows in buildings. You can see the model is predicting reasonably close to the measured flow here. The red dots you see are the minimum design flow rates from any of the codes we could access. And what I haven't included is the range of codes that we have access to in the UK and that actually give much higher design flows. So we're managing to get much closer to be able to predict the design flow in buildings, in this case in residential, but also in non-residential. But that simply would not have been possible without the collaboration between the various organisations. So can I ask you now as I close, can I ask you to think again about academic research and its role in industry and collaborating and being able to establish this new knowledge? At the beginning I said we're really, really keen to hear about your challenges and the difficulties you face in the plumbing industry. And we like nothing more as an academic to get our teeth into some of those issues. And we're very happy to work together with a whole range of organisations to come up with solutions. And hopefully from the example I've given you on water demand, you've seen just one example of many, actually. Thank you very much.